Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? This is our second lecture of grade 10th. The chapter name is Chemical Industries and the topic name is Extraction of Metals, Manufacture of Sodium Carbonate by Solvay Process. First is extraction of metals. When the ore is free of gangue and concentrated, you have poured the metal free from gangue and concentrated impurities. Metal is extracted from it. It is converted into oxide of the ore. First of all, we will convert the concentrated ore to its oxide. It is easier to obtain a metal from its oxide form as compared to its sulfide, carbonate, or any other form. Therefore, prior to reduction, usually the metal is converted to its oxide form. Because in sulfide and carbonate form, it is difficult to convert in these forms. Following methods are used to convert the concentrated ore to its oxide form. The first one is roasting. It is also called as red hot. The process in which the concentrated ore is heated either alone or with some other materials in excess of air in a furnace. The solid gas reactions are used to chemically transform minerals. As an example, roasting is used to remove sulfur from sulfide ores. The ore is heated in an oxidizing atmosphere, such as air. Sulfides are oxidized by the oxygen in the air, with the sulfur liberated as sulfur dioxide gas, leaving an oxidized mineral. For example, zinc sulfide reacts with oxygen to form zinc oxide. We are converting sulfide to its oxide. As we have studied that conversion into oxide is easy as compared to conversion into sulfides or carbonates. So in this reaction, zinc oxide and sulfur dioxide is formed. The sulfur dioxide produced in the process is a significant air pollutant. For example, that from smelting around Queenstone, Tasmania, killed off all the vegetation, making the place look like another planet. The concentrated ore is roasted in a furnace between 500 and 700 degrees centigrade in the presence of a current of air. Ores of metals such as copper and nickel, when roasted in air, are converted into their oxides, and sulfur is converted to sulfur dioxide. We are converting the metal or the ore in its oxides, while ores of some metals like lead are partially oxidized and converted into sulfate. This is an example of roasting. The first one, CuFeS2, is basically the formula for chalcopyrite. The chalcopyrite reacts with oxygen to form cuprous sulfide and ferrous sulfide and the liberation of sulfur dioxide. The cuprous sulfide and ferrous sulfide are further oxidized into their oxides. Cuprous sulfide reacts with oxygen to form copper oxide plus sulfur dioxide. And ferrous sulfide react with oxygen to form ferrous oxide plus sulfur dioxide. You can see here, you can look that sulfur is converted or sulfides are converted to oxides. Similarly, let's take another example of copper hydroxide. The copper hydroxide forms copper oxide plus liberation of water along with it. Smelting. The smelting is the process in which oxides which are formed in the roasting process are reduced into the reducing agents such as coke. The oxides are reduced with the help of reducing agents such as coke or carbon. So we can call the smelting process as reduction by carbon. Smelting is carried out in blast furnace, hot air blast, melting zone, reduction zone, preheating zone, or silica coke, exhaust gases that are removed, column of or silica coke, removal of slag, molten matter, and collection of waste gases. This all apparatus is given in the diagram. The roasted ore is mixed with coke, means the oxide is mixed with coke and silica, that is silicon dioxide, and is introduced into a blast furnace. The hot air is blasted and iron oxide is converted to ferrous silicate. Iron silicate is a slag. Slag means that iron silicate is an impurity. It is lighter than the molten sulfides of copper and iron, hence, it is removed at the upper hole. Here is the reaction. The iron oxide reacts with silicon dioxide to form iron silicate. The copper oxide and iron sulfide then reacts to form copper sulfide and iron oxide. The third is Bessemerization. Bessemer process was first invented by Henry Bessemer. This process is carried out in a special kind of egg-shaped or pear-shaped furnace. This furnace is called as Bessemer converter. Basically, this is an egg-shaped or pear-shaped furnace. The copper metal is extracted from the molten matte through Bessemerization. The matte is introduced into the Bessemer converter, which uphold by tires. The air is blown through the molten matte. Blast of air converts copper sulfide partly into cuprous oxide, which reacts with the remaining copper sulfide to give molten copper. Here is the example of Bessemerization. The copper sulfide reacts with oxygen and form cuprous oxide plus sulfur dioxide. Similarly, cuprous oxide combined with copper sulfide to form copper and sulfur dioxide. You can look at this diagram. The hot air is entering inside the furnace. The tires are at the bottom of the end section of the furnace. The furnace consists of fire clay bricks. The inside of the portion of the furnace is made up of steel, and above the layer of hot air, a slag means impurities are present which are being removed at the end of the process. Next is electro-refining or electrolytic refining or purification of metals. Electro-refining of metals is a process of obtaining pure metal from the impure one by the process of electrolysis. It means that we have to remove the impurities from the metal and the metal become pure. Many metals such as copper, zinc, tin, silver, gold, etc. are refined electrolytically. The impure metal is made anode and a thin strip of pure metal is made of cathode. Solution of the metal salt is used in electrolyte. The process of electro-refining of copper involves the following steps. First of all, a large plate of impure blister copper is made as the anode. This is the impure blister copper and we are taking it as anode. A thin rod or sheet of pure copper is made as the cathode, and the sheet of pure copper we are taking it as cathode. Cathode is negatively charged. Third one is the electrolyte is copper sulfate, that is CuSO4. and dilute sulfuric acid H2SO4 solution is used. The electrolyte for electrorefining that we have used is copper sulfate and sulfuric acid. First, we have taken the impure blister copper, which we have taken as anode, a thin rod or sheet of pure copper, which we have taken as an cathode, and the electrolyte is copper sulfate and dilute sulfuric acid solution is used. Now the potential difference is 1.3 volt in this process. During electrolysis, the pure copper is deposited on the cathode plates. As we have already studied that a thin rod or sheet of pure copper is made as the cathode. So the pure copper is deposited on the cathode plates. The impurities, that is silver, gold and platinum mud along with copper oxide in the anode, settle down at the bottom and are removed as anode mud. The pure copper is present at cathode, while the impurities are present at anode and are removed as anode mud. The copper obtained by this method is 99.9% pure. The pure copper was present at cathode. The next is the solvay process. The solvay process was first used for the manufacturing of sodium carbonate. This is a crystalline decahydrate and the formula for crystalline decahydrate is sodium carbonate.10H2O. It is synthetically produced in large quantities from sodium chloride, ammonia and limestone in a process known as the Solvay process. Ernest Solvay was a Belgian chemical engineer. He prepared sodium bicarbonate and sodium carbonate for the first time from cheap and abundantly available raw materials such as limestone and sodium chloride. The processes that are involved in Solvay processes are the preparation of brine solution. In the first step, a saturated solution of sodium chloride is prepared, which is also known as brine. In the second step, saturated brine solution is allowed to flow down an ammoniating tower. This tower is fitted with mushroom-shaped baffles, which ensures the proper mixing of ammonia gas in the brine, which is a saturated solution of sodium chloride. Now we mix ammonia in that saturated solution of brine. Ammonia is dissolved in brine. In the third step, carbon dioxide is produced by heating limestone, that is calcium carbonate. By heating calcium carbonate, calcium oxide and carbon dioxide are formed. Carbon dioxide is fed into the carbonating tower from the top. Calculated amounts of quicklime, that is calcium oxide and water, are mixed to produce slaked lime, that is calcium hydroxide. The calcium oxide plus water reacts to form calcium hydroxide. The fourth step is carbonation of ammonical brine. In this step, ammonical brine is allowed to enter the carbonating tower, also known as the Solvay tower. In this tower, the ammonical brine is mixed with carbon dioxide gas. The carbon dioxide is converted into small bubbles. Carbon dioxide reacts with ammonia to form ammonium carbonate, as we have to recover ammonia at the end of the Solvay process. So we react the carbon dioxide with ammonia to form ammonium carbonate. Likewise, ammonia react with carbon dioxide and water to form ammonium carbonate. The ammonium carbonate then reacts with sodium chloride and forms sodium bicarbonate and ammonium chloride. This is the exothermic nature of the reaction, and solubility of sodium bicarbonate increases. The temperature gets lowered to 15 degrees centigrade. At this temperature, sodium bicarbonate is precipitated. Now the precipitates of sodium bicarbonate get separated from the solution with the help of filtration from the carbonating tower. That we are removing sodium bicarbonate from the carbonating tower with the help of filtration. And this sodium bicarbonate can be used as baking soda. The next step is calcination. In the calcination, the sodium bicarbonate is heated in a furnace called as calciner. It gives anhydrous sodium carbonate or soda ash along with carbon dioxide and water. In the last step, there is recovery of ammonia, and this is the last step of Solvay process. Ammonia from ammonium chloride solution is recovered in the Solvay tower and slaked lime formed in lime kiln. Slaked lime is heated with ammonium chloride to form ammonia and calcium chloride, that is the byproduct. Almost all the ammonia is recovered in this process and is used again in this process. The products sodium carbonate and sodium bicarbonate are important industrial chemicals and used in many products. So this is the general pathway of Solvay process. The Solvay process is the method of making sodium carbonate from the raw materials sodium chloride, ammonia and calcium carbonate. It was first presented by Ernest Solvay in 1860s. So the sodium chloride reacts with limestone to form sodium carbonate and calcium chloride. The 4 steps are involved. First is brine purification, second is sodium hydrogen carbonate formation, third is sodium carbonate formation, and then ammonia recovery. First, the saturated solution of brine is prepared. The brine is concentrated by the evaporating impurities. Brine solution is then filtered through an ammonia tower to dissolve ammonia. Carbon dioxide is produced by the thermal decomposition of limestone, as we have already studied. Then calcium carbonate forms carbon dioxide and calcium oxide. This calcium oxide then converts to calcium hydroxides by reaction with water. The carbon dioxide is bubbled through the ammoniated brine solution in the carbonating tower. The carbon dioxide dissolves to form a weak acid. The ammonia in the brine reacts with hydrogen ion to form ammonium ions. The sodium bicarbonate is heated at 300 degrees centigrade to produce sodium carbonate, and from sodium carbonate, ammonia is recovered. The calcium hydroxide reacts with ammonium chloride to form calcium chloride, water, and ammonia. This ammonia is recovered in the process. Almost all of the ammonia is recovered in the Solvay process. Calcium chloride formed in this process is used as a byproduct and does not have any use. The ammonia that is recovered at the end of the Solvay process is released into the atmosphere. This is the general flow chart for the Solvay process. In this process, sodium carbonate is formed at the end. It means that sodium carbonate is involved in the formation of Solvay process. This is an outline for the basic reactions of Solvay process. Thank you so much.